You have studied how the trigonometric functions such as sine x, cosine x, and tangent x can be used to find an unknown side length of a right triangle, or if one side length and an angle measure are known. The inverse trigonometric functions such as sine inverse x, cosine inverse x, and tangent inverse x are used to find the unknown measure of an angle of a right triangle when two side lengths are known. Inverse trigonometric functions do the opposite of the regular trigonometric functions. This is expressed mathematically in the statement below. The domain and range of the inverse trigonometric functions are summarized in the table below. Now, let's take a look at problems involving trigonometric functions. This question asks you to solve the trigonometry equation within the interval of 0 to 360 degree. The expression is given as follows. Solve sine theta cosine theta equal to negative 0.5. When you try to solve this problem, recall the trigonometry identities. 2 sine theta cosine theta equal to sine 2 theta. Then, sine theta cosine theta is equal to sine 2 theta over 2. Therefore, the left hand side can be replaced with sine 2 theta over 2 equal to negative 0.5. Then, you need to solve for sine 2 theta equal to negative 1. When you try to determine the value for theta, let's try this approach, such as determine the reference angle first. The reference angle can be determined by ignoring the negative sign first. The reference angle for this question is as simple as sine inverse 1. When you use your calculator, please make sure your calculator is in radian mode. The original equation given to us sine 2 theta equal to negative 1 means that we are trying to determine the value for theta where sine function will be negative. Based on the figure that we have discussed earlier, sine theta will be positive in the first and second quadrant only. Therefore, within the interval 0 until 360 degree, the value of theta can be determined by having these informations, such as the sine is negative at the third and fourth quadrant. Hence, explain why I use this as the way to determine the value of theta. Since it will give us the same answer, which is 270 degree, therefore, theta is equal to 3 pi over 2 in order to satisfy sine 2 theta equal to negative 1. Now, let's take a look at the following question, which is determine sine squared theta minus 2 cosine theta minus 2 equal to 0. Again, in order to solve this problem, we have to use the trigonometry identities. This time around, we will apply cosine 2 theta plus sine squared theta equal to 1. Sine squared theta is equal to 1 minus cosine 2 theta. Based on the original expression given to us, replace sine squared theta with 1 minus cosine squared theta. You will end up having negative cosine squared theta minus 2 cosine theta minus 1 is equal to 0. Or if you bring the whole thing on the left hand side to the right hand side, you will get cosine squared theta plus 2 cosine theta plus 1 is equal to 0. By factorize completely, you will end up having cosine theta plus 1 squared equal to 0. Then you are trying to solve for cosine theta equal to 1. Based on our information, we know that theta will be positive in the first and fourth quadrant only. Therefore, in order for the cosine function to be negative, it will need to be located either at the second quadrant or the third quadrant. By ignoring the negative symbols, we are looking for the reference angle. Then, by using your calculator, you will know that the reference angle is equal to 0. By referring to the diagram that I have sketched over here, in order to determine the value of theta by using the reference angle we have obtained earlier, you will perform something like this. Since they end up giving you the same answer, therefore, theta is equal to pi in order to satisfy cosine theta equal to negative 1. Now, let's take a look at this question. Again, this question asks you to determine the value for theta within the interval of 0 to 360 degree. You will get cosine theta is equal to 1 over 2. Again, try to look for reference angle first instead of searching for the value for theta. In this case, the reference angle for this question is cosine inverse 1 over 2. By pressing your calculator, you will get pi over 3 or 60 degree. By referring to the diagram that I have sketched in this solution, the diagram shows how alpha or reference angle is measured. Since we are looking for possible values of theta and at the same time the cosine function is positive, based on the diagram I have showed earlier, cosine will be positive in the first and fourth quadrant. Therefore, based on that facts alone, the theta can be found in the first quadrant as 60 degree. Meanwhile, the next possible values for theta is at the fourth quadrant. Since the way we measure our theta is always from the positive x-axis, therefore 360 degree minus 60 degree equal to 300 degree or equivalent to 5 over 3 pi.